Hello, I would like to present here research about behavior of timber concrete composite with defect in adhesive connection. Timber is a renewable material, what makes the significant advantage for its use in construction, but concrete is the most widely used man-made building material. Timber concrete composite structures can ensure more efficient use of resources and meet the growing demand for sustainable structures. Combining such two materials as timber and concrete, we can improve various classical disadvantages of wooden floors. The most efficient way to combine advantages of timber and concrete is providing of rigid connection between timber and concrete layers. As you can see on the slide, full composite action provides a high bending stiffness, which results in smaller deflections, and can provide concrete layer action only in compression zone. But there is one important moment. It is difficult to predict the quality of the obtained connection with the classic production method of continuous rigid connection when timber layer and precast concrete layer are simply glued together. So the aim of this study is investigation of the effect of non-glued areas in connection between composite layers on the shear stresses and energy absorption. Also, method of creating qualitative connection between composite layers is offered. On the slide you can see proposed production method of rigid connection between timber and concrete layers. It provides preparation of timber base, applying a glue layer on timber surface, gluing of granite chips, and after drying of gluing layer, placing of fresh concrete. To investigate the effect of the adhesive connection on behavior of timber concrete composite subject to the flexure, two types of specimens were prepared. The first specimen was sealed panel glued together with precast fine-grained concrete layer with strange class C20 and additional carbon fiber plate glued on sealed surface in the tension zone. The second specimen was identical to the first, but a rigid connection was produced by proposed method, which include gluing of the granite chips with dimensions 16-25 millimeters to the sealed surface. Both specimens types with 1.8 meter span were tested in a 3-point bending until the collapse. Here you can see comparison of the behaviors of timber concrete composite specimens produced by classical dry method and proposed method. As it can be seen, the timber concrete composite without granite chips develops much larger displacements than those obtained in the concretions. At a load level of 30 kN, the experimentally determined displacements are equal to 22.8 millimeters, what is more than 52% larger than those calculated with the 3D damage model. At the same time, proposed production method of rigid connection provides full composite actions of the specimen and additional local strengthening. The specimen with granite chips showed both high load-bearing capacity as well as smaller maximal vertical displacements. The average destructive load of this basement was 41 kilonewtons, and for timber concrete composite produced by classical method, destructive load was only 32 kilonewtons. Maximal displacement of the load level of 30 kilonewtons for timber concrete composite proposed production method was smaller than 6 millimeters. As you can see, experimentally obtained behavior of timber concrete composite panel produced by classical dry method is characterized by less stiffness in comparison with analytically and numerically obtained. The reason of this is poor quality of obtained glued connection by classical dry production method. Strengthening effects of the concrete layer by granite chips can be explained by this figure. Cement paste has worse strength than aggregate, so granite chips as concrete aggregate luckily increases the strength of concrete, which is observed at the stage when nonlinear behavior begins to develop in timber concrete composite. To determine the effect of low-quality glued connection on the load-bearing capacity of timber concrete composite elements subjected to the flexure, 3D numerical models with different size and amount of qualitative contact surfaces were developed. Here you can see adapted schemes of the qualitative glued areas in connection between timber and concrete layers. The first part of the study shows that poor quality areas with the same length provides very similar level of the shear stresses regardless of the total amount of defective areas. According to the second part of the study, the maximum shear stresses increase trend by the increase of the area of the separate non-glued area has been identified. Here you can see numerically obtained load displacement curves for basement with defect area of 30, 40, and 50%. It can be concluded that large separate areas with defects in adhesive connection can significantly affect the energy absorption of timber concrete composite subjected to the flexure. Displacement values at a load level of 30 kilonewtons for two types of timber concrete composite basements obtained experimentally confirms numerical obtained results. As can be seen, the displacement value of timber concrete composite produced by classic dry method is close to the displacement value obtained for model with 40% area without adhesion between the concrete and timber layers, which is confirmed by a photo of the collapse of the basement. This example demonstrates the importance of quality of connection and can explain the drastically different behavior of the samples. As a result of the research, the following main conclusions were obtained. Defects in adhesive connection between timber and concrete layer may be the cause of the drastically different behavior of timber concrete composite. The use of classical production method for rigid connection is dangerous because it is difficult to predict the quality of the obtained connection. So it is not safe to predict the behavior of such timber concrete composite by models with the full composite action. The rigid connection produced by gluing of granite chips allows visual control of the glued connection quality and provides naturally developing of the bond between concrete matrix and granite chips as aggregates of concrete. Moreover, granite chips can provide local strengthening of the concrete. The increase of shear stresses is influenced not so much by a total amount of non-glued areas, but by the size of the individual defective areas. Large non-glued areas significantly reduce the energy absorption of elements subjected to the flexure. Thank you for your attention.